Another example of graphing a parabola, but in this case we're going to look for the axis symmetry first. Where the perfect square one, we would look for the vertex first. The formula for the axis symmetry is x equals negative b over 2a. Kind of like the quadratic formula, b is the second coefficient, a is the first coefficient. So in this case, b is equal to this positive 4, don't play with the x, just the coefficient. So we're going to get negative positive 4 over 2 times a, and in this case a is equal to negative 1. So we'll put in negative 1. So this becomes negative 4 divided by negative 2, better known as 2, positive 2. So the axis symmetry has a equation of x equals positive 2. This is that vertical line that'll hit on the x-axis at 2. Alright, from this, since we know what x is equal to, we might want to know what coordinate lies on there, on this function, on when x is equal to 2. So all we're going to have to do is plug it in. So we're going to find f evaluated at 2, which will be negative 2 all squared, well, not all squared, but negative 2 squared, plus 4 times 2, plus 5. And then on simplification, this becomes negative 4 plus 8 plus 5, better known as positive 9. So our vertex is going to have a coordinate of 2 for the x and 9 for the y, better known as 2, 9. And then we can go about finding x-intercept and y-intercept like we did before. So the easier one, of course, is y-intercept. And to find the y-intercept, we'll let x equal 0. So we're going to find f of 0, and we'll have negative 0 squared plus 4 times 0 plus 5, better known as just plain old 5. So that'll give us a coordinate of x is equal to 0, y is equal to 5. And then we can find our x-intercepts, and I hope I have enough room. And we're going to let y equal 0, or the whole thing equal 0. So we're going to have 0 is equal to negative x squared plus 4x plus 5. Now we could use the quadratic formula, but I'd rather try to factor it. To factor it, we need a positive x squared, so I'm going to multiply everything by a negative 1. And then, are there factors of 5 that subtract up to 4? Negative 4 in this case. And there are, it would be 5 and 1. So this thing is going to factor into x minus 5 and x plus 1. Don't forget that this whole thing is still equal to 0. So we're going to get an x-coordinate out of this one of positive 5, 0. That's what's going to make that first one equal to 0, 5. This one's going to give us negative 1, 0. So here we have our vertex, our axis of symmetry, our y-intercept, and our 2 x-intercepts. Let's see what the graph is going to come out to be. So let's plot all the information we have here. First off, the vertex is at 2, 9, so we'll go 2 to the left and 9 up. So we'll plot a point here. 0, 5 is the y-intercept, so we'll plot it right there. 5, 0, 5 to the right, and negative 1, 0, 1 to the left. Now remember, we have this axis of symmetry coming right down the middle here, and we're going to have to reflect our y-intercept. Well, it's 2 units away from the axis of symmetry, so all we have to do is go 2 more units. So we'd be right here at 4, positive 5 would be the coordinate. Alright, and then we can just graph our parabola. And then we have our graph of f of x equals negative x squared plus 4x plus 5. That's it.